Now see here, this is the relation between focal length and radius of curvature of mirror. That means a spherical mirror may be for the concave or convex. Suppose you have taken concave mirror like this, and this point is the pole of the mirror, and this is the line passing through this, that is the principal axis. I have taken approximately here somewhere guessing part, this is the center of curvature, that is the C. I take one incident ray which is parallel to principal axis. After reflection it passes through a point, and this point is known as focus. Now, if you draw a ray from the center of curvature, that is considered as normal. So, this is angle of incidence, suppose I have taken theta. So, this also will be here theta, because angle of incidence and angle of reflection are equal. So, if this is theta, this is also theta here, because in this case, sorry, here this is theta. So, this whole thing is here the 2 theta. So, this we can take as 2 theta, and also this is theta. So, we can write this one is also theta, that is alternate angles. So, this 2 theta can be taken also an exterior angle. For the here this point we have taken suppose L. So, for the triangle here LCF, this 2 theta is an exterior angle. We draw a perpendicular from here, that is M. Now, first we take triangle. In triangle here LMF, right angle triangle, we can write tan 2 theta is equal to LM upon here MF, and in triangle LMC we can write tan theta is equal to LM upon MC, and see here these angles are small angles. So, we can write here tan 2 theta is approximately, that is equal to only 2 theta, and we can write tan theta is also equal to only just theta, because the angles are small. So, we can write in this case here 2 theta is equal to LM upon MF, and here theta is equal to LM upon MC. Now, we can equate these two, we can solve it here. So, when we solve these two, we are going to get it here. In place of this theta, I am putting this value here. So, that is twice of LM upon MC is equal to LM upon MF, this LM cancel. So, twice of MC is equal to 1 upon MF. Now, see here, this mirror or the mirror has a small aperture. So, we can also write here MC is approximately equal to here PF, sorry, that is here the PC. So, M and P are considered very close. So, M and P are very close. So, the MC is approximately equal to PC, that is equal to radius of curvature, and this distance is opposite to the reflected ray. So, we can write here minus R. Similarly, we can write MF is approximately equal to PF is equal to minus F, because the distance between focus and pole is known as focal length. Now, we replace these values over here. So, we will be getting 2 upon minus R is equal to 1 upon minus F, or we can write here F is equal to R by 2. So, this is the relation between the focal length and radius of curvature. It means radius of curvature is twice of the focal length, and same formula can be derived for the convex mirror also. So, in exam it can be asked in either way, that means it may be for concave mirror or convex mirror.